question 9 is coming from quadratics, but express this in the form, this one, where a and b are constants. So here we can do it in two ways. You pick the one that is easier for you, okay? So I'm going to use completing squares right away, and then the other one I expand and then equate the coefficients. So the first thing we do here, first of all, we have this one here. If I have x plus a squared, this one is going to be equal to x squared then plus 2ax then plus a squared. So I want a side that has only x, so I can bring this one this side, and then I get x plus a then squared minus a squared, which will be equal to x squared plus 2ax. Okay, now I want you to look at what is done here. This 2a is actually divided by 2 to give us the a that is here. And then after that, it is popped outside here and squared. Do you see the process? Now, that means I'm going to come here. The first thing I'm going to do is to factorize, okay? Factorize out the 2 because the coefficient of x squared here is not 1. So let us first pull out that 2. And then we have x squared plus 6x. I can leave the 11 outside here. I'm only interested in this part here, just like this one here, okay? Now, the next thing to do is to get this part. We have seen that the coefficient of x here is divided by 2. So when we divide 6 by 2, we shall get a 3. So that 3 here, then we pop it outside here as a square. So it will give us minus 3 squared, just like that. Then close the brackets and then plus 11. So the next thing is to open the brackets. So this 2 multiplies everything here. Then we shall have 2 into x plus 3 squared. This is 9 times 2, that will be 18. So minus 18, then plus 11. Minus 18 plus 11, of course, that one gives us a minus 7. So that means we shall have 2 into x plus 3 bracket squared, then minus 7. That is that, okay? Then alternatively, we can expand and then equate coefficients. So alternatively, we can have this. We say 2x squared plus 12x plus 11 is the same as 2 into x plus a, then squared, and then plus b here. So open the brackets, this will be 2. First of all, here when you expand, we shall get x squared plus 2ax, then plus a squared, then plus b. So when I open the brackets, I will have 2x squared, then plus 4ax, then plus 2a squared plus b. And of course, here we have 2x squared plus 12x plus 11. Now we equate the coefficients. So the coefficient of x squared here is a 2, even here is a 2. So that one is gone. Then here we have 12, and then here we have 4a. So when we divide all through by 4, that means a is going to be equal to 3. And then the constant part here is 11. Then I will equate to the constant part here, which is 2 into a, which is 3 squared, then plus b. This one is 9 squared, which I mean 3 squared is 9 times 2. That one will give us 18. And then when it comes to this other side, it will come there as a negative. So 11 minus 18, this one will give us the b, and b becomes negative 7. And then from there, I conclude and say that 2x squared plus 12x then plus 11 is the same as 2 into x plus 3 squared then minus the 7. You just put these values in the places of a and b. Our a here is the 3, and then our b is the negative 7. Don't get confused when they say plus b here and then the answer you have gotten here is a negative. B can be a positive or a negative, okay? So this is our answer, just like this one here. The function f is defined by this one for x less than or equal to -4. Find an expression for the inverse and state the domain of f. This one here is the same that we have looked at in part A. Okay, they have helped us to first tell us to express it in this format, because you cannot find the inverse, you cannot make x the subject of the formula here unless you use this completed square format. So I'll write my f of x here to be 2x plus 3 then squared minus 7. So if the inverse is equal to y, I'll take this one this side, it will come there as f. So x is going to be equal to f of y. In other words, interchange x and y. So we shall have x, which is equal to, now 2, where there is x, I will put a y, then plus 3 squared minus 7. Now bring this one this way. We are now making y the subject. So we shall have x plus 7. Then from there, I think we can divide by 2. And then we have y plus 3, then squared here. Now take the square root. When you take the square root, of course, you must have plus or minus, which will be y plus 3. Okay? Then from there, now take this one this side. So when I take it here, it will be minus 3, then plus or minus to the root of x plus 7 out of 2, which is equal to y. That means the inverse of this function is going to be -3, then the square root of x plus 7 out of 2. Then that is that. But we are not supposed to put plus or minus. When you write your answer like this, it is going to be crossed, because a function has gotten an inverse if and only if it is 1 to 1. Okay? If you have been following me, I've always said that you have to look at the domain that is given. So since this one is a quadratic function, okay, it's a quadratic function, we are going to have u here, a u-shaped curve, okay? And the turning point here is going to be, just get this one and equate it to 0. That will be a -3, and then the y coordinate is this one, that is -7. So all y values are going to be above this -7. So that means the range is actually supposed to be f of x. Okay, f of x greater or equal to -7. The rest are greater than that 7. Okay, but this one is valid for x. We are looking at the turning point here, because the function gets to have the turning point, I mean the inverse, at that point where it turns off from. So for it to have an inverse, first of all, we are seeing that this one is not a one-to-one function. So there is an x value here, and then there is a y value here. Okay? Now, for those two y values, I mean, there is an x value here, and then an x value here. These two x values are giving us one y value here. Okay? So that is many to 1. Are we there? So if it is many to 1, then this one implies that it cannot have an inverse. It has to be a 1-to-1. So what they do to make this one a 1-to-1, they look at the left of this one, of the turning point, or the right of the turning point. Now, the x coordinate here, we are seeing it is -3, and this one here is -4. That means they chose the left side. Are we there? So since they are choosing the left side, there is that value of x, which is -4. It has to correspond to a certain y value. So we have to get that y value that corresponds to x being equal to -4. Now, we can get f of -4. We can substitute here, or you can use this one here. So we can have 2 into -4 plus 3. That will be a -1. When you square, that is a +1. then times 2, that will be a 2, minus 7, that one will give us a negative. We shall get negative 5, okay? So this negative 5 that we have gotten here, now we are beginning from this negative 5, and then since it is less than or equal, we are continuing to this other side like that. So we are going, remember this one is going to continue, and then you will get values that are also greater than that negative 5. Now we are not starting from this negative 7, we are starting from negative 5 based on this domain here, okay? So this implies that the range, I'll say that for x less than or equal to negative 4, range of f shall be f of x which is greater or equal to negative 5, okay? Negative 5. Now, the domain, I want us to look at this one here. If we have x values here and then we get y values here, so a function acts on x, then we get f of x. So this one is its domain, because what you put in the function is the domain. Then what comes out is the range. Then we know that the inverse is the one that undoes what the function has done, okay? So this is the domain. Remember, what you put in the function is the domain. So this part here is what you are putting in this function to get what is here. So this will be the range. So this simply implies that the range of f is actually the domain of the inverse, okay? So meaning, and here they say state the domain of the inverse. So domain of the inverse here is going to be this one here, okay? But domain is written in terms of the independent variable, then the range is written in terms of the dependent variable. In other words, we write the domain in terms of x and then the range in terms of the function. So you remove this and then you put x. So we shall have x then greater or equal to negative 5. Now I had forgotten to put a sign here. Now since we are looking at the left side of the turning point, then we are going to take the negative. If the domain which was given was on the right of the turning point, then we take the plus, okay? So here we must have a minus. Then the function g is defined by this one here, for which x is less than or equal to k. For the case where k is negative 1, solve this equation here. Okay, now we need to put f into the g. Remember our f of x here, we got it as 2 into x plus 3 bracket squared, then minus 7. So this is 2 into x plus 3 bracket squared, then minus 7. Now we need to put g of x then where x is, okay? So we shall have f g of x is going to be equal to 2, then inside here we have g of x plus 3, okay, then squared and then minus 7. This is 2 into the g of x is 2x minus 3, then plus 3, then squared, minus 7 here. Then we shall equate this one to the 193. Now, of course, this one will disappear. And then when we square this one here, it will be a 4x squared, then times 2, that will be 8x squared. I can take this one, this other side, it becomes a plus. So that will be 200. And then our x here is going to be plus or minus the square root of 200 divided by 8. Okay. By 2, this one here is 100. By 2, this one is 4. 4 goes into 100 25 times. So square root of 25, that one gives us 5. So we shall have plus or minus 5. But they said that for this one, it is valid for x less than or equal to negative k. So if it is -1, then we have x less than or equal to -1. So which of these two values falls within here? Okay, even the domain of f, we are looking at x, which was less than or equal to -4, you see? So we have to take the -5. So our x is going to be equal to -5, as simple as that. Then part D, state the largest value of k possible for the composition of fg to be defined. Now, what we are going to do here, for this one to be composed, remember we have x here, then g acts on it, and then we get g of x. Then from there, f acts on this one, and then we shall get f g of x. Okay? Now, what we put in the function is its domain. If what we put in the function is its domain, now what we get here is the range of g. So the range of g must be in position to fit into the domain of f. Okay? The range. In fact, let me write this. For fg to be defined, the range of g must fit into the domain of f. We shall go to the domain of f. The domain of f is here, x less than or equal to -4. Now, when we are composing, we are putting g in the place of x. So the domain of f, is x less than or equal to -4. So meaning I'll get the g of x, I substitute it in the place of x, because when we are composing, g takes the place of the x in f of x. So I'll put the g here, the g of x, which is given as 2x minus 3. So I'll write 2x minus 3, then I will say less than or equal to the -4. And then I solve for x. So when this one comes this other side, it will go there as a plus. Then we shall get -4 plus 3, that is a -1. And then x becomes less than or equal to -1/2. Now this one is going to come into this format. See, x less than or equal to -k. So x less than or equal to less than or equal to k. Now this is going to be the k here. So we can say, therefore, the largest value of k is -1/2. That is that.